Hello there, I hope you all are doing well. In this video, we want to talk about the Rhinoceros, or typically abbreviated as Rhino, for those who are working with Rhino for the first time. Firstly, I should say that the Rhino software has been developed by Robert McNeel and the Associates in Seattle, America, and he was one of the Autodesk programmers that they managed to program this software, Rhinoceros or Rhino, which is a professional computer-aided design application software in graphics and 3D design. And several versions of Rhino have been released since 1993, and currently the latest version that has been released by this company and that is accessible is Rhino 8 SR, abbreviated as Service Release 10, which is the latest version of Rhino 8. That we want to move our project forward on Rhino 8 SR10. But why should we use Rhino 3D? In general, if we want to question that, why should we use Rhino? I should say that Rhino is a powerful and also low in size, precise in modeling, 3D modeling, and also presenting, and most of the functions like analyzing or connecting it to some devices for manufacturing. In fact, if we want to divide the modeling softwares to two groups of CAD or computer-aided design softwares and also CAM, computer-aided manufacture, I should say that Rhino can be included in both of the types of groups, both CAM and CAD. And the current modeling system in Rhino is NURBS system, which stands for Non-Uniform Rational B-Spline Modeling. And the non-uniform part denotes that NURBS can be used to create freeform shapes. However, it includes multiple modeling systems. However, firstly, I just want to give you a brief explanation about the differences of modeling systems. There are three main modeling systems that are called Mesh, that is used in softwares like 3D Max, SketchUp, that these softwares are using this modeling system, and also NURBS modeling, as mentioned, that we are dealing with this modeling system in Rhino. However, we got the NURBS modeling in 3D Max as well, but you should note that we do not use the NURBS modeling in 3D Max and also mesh modeling in Rhino. And note that in Rhino we got sub-D modeling as well. That I'll tell you the main differences between them. We were supposed to talk about creating panels by two devices or two mediums of Rhino and also Grasshopper, which is a visual programming language or platform built in Rhino. So here we got a software, which is Rhino, and also a plugin that it is going to be installed on Rhino, which name is Grasshopper. And also I want to instruct you how to create a 2D patterns in these two softwares, Rhino and Grasshopper, comprehensively. Firstly, let's talk about Rhinoceros. In general, by using the 2D and 3D patterns, by using the Rhino commands, we can create the 2D and 3D patterns, and also creating some fixed and repetitive modular patterns. Suppose that we get some rectangles, duplicate it, and we got the base pattern or the base module that has been propagated, that we can propagate or duplicate these patterns on a straight surface or in some complex surfaces. However, we can propagate the 3D patterns on the planes or on a complex and curved surface. That we'll talk about all of them. And also the Rhino plugins that can be installed on Rhino. Note that we are talking about the plugins except Grasshopper, that we can create some 2D and 3D patterns using these plugins. Anyway, firstly let me launch Rhino 8 At first, we want to get through some details about the modeling systems in Rhino, and then we want to exemplify some cases. However, some of you may have some classes with me that you may find these repetitive. Suppose that we want to model or draw a sphere 10-foot radius. Here, if we want to model this using mesh modeling, this will be the result. And if we want to model it from or using sub-D sphere, look this is the result. Here, firstly, we have modeled it using NURBS, that here we got a smooth and precise surface, as you can see. And as you can see, everything is perfect here, smooth and precise. But here, as you can see, in mesh modeling system, there are some segments, as you can see. But if I want to increase the precision, I must increase the faces actually. I specify 40 faces, watch this, and then this will be the result. However, it is more close to the NURBS modeling. But still we got these segments if we zoom in. And as much as we increase this value of division, we are increasing the file size. So, the first difference between these two systems, here as you can see, we got a united and solid object here that we got no access to the interior parts, but in mesh, as you can see, we can select the panels and then move them independent to others. Watch this. This is the result. And if we move the selected parts, we can select the edges or the faces or the points or the vertices. Look, we can select them easily and deform the object. Watch this. We are deforming it. And if I combine these two modeling systems, we'll have sub-D. Watch this in a simple definition, that we can get access to each of the faces, watch this, and when we move it is still smooth. And let me start the command of sub-D sphere again. Here I want to increase the division, watch this, and also in this simple example, we can create or model different types of spheres. Watch this, or another type. Here we got 3D types, three types. I mean, here we got three types of quad, UV, and triangular with different divisions. And also, watch this, we can select the faces and move them by click and drag and deform the object with wonderful capabilities. For instance, I can cut this, look, and we can use it in Format software and also in Blender and also in Elias, which is a software used in automotive design, by this way. And I want to select these two parts and create a bridge between them to connect them, like this way. And then I curve this section and also selecting this face. Look, we are free to deform it in a simple way. Anyway, forget about it. In Rhino, we got the three systems of modelings, as I mentioned: NURBS, sub-D, and mesh. But note that we mostly use the mesh modeling system when we want to use it in Grasshopper actually. It's mostly used in Grasshopper, and in Grasshopper we save the points, the vertices, and also their coordinations, the bases, and all of the related information and data related to the segments or the edges, points, and the faces. And when we want to make them smoother, we're gonna have more information and data, and as a result, greater size of the file. Anyway, the first thing that I want to talk about the Rhino commands and also the Rhino plugins in this slide. Let me go to the next slides. Anyway, as mentioned, we use the Rhino commands for creating the 2D and 3D patterns, and we got access to these tools and commands without having any plugin installed. I mean, there is no need to have these commands installed. You can have access to them by just having the software installed on your device. Firstly, we want to talk about the two commands in this session. Anyway, as you can see, we got the commands of create UV curve, apply curve, and flow long surface. And if you needed the instructions or the video tutorials about these commands, you can ask me for them and I will share them with you. Anyway, as I was saying, there are some commands that we use them for creating the 2D and 3D patterns on the surfaces. I mean, firstly, we draw them or we create them on the plane. That firstly, I want to teach you how to model these on the planes within multiple examples, and then you'll learn how to transfer them on the complex and curved surfaces. Anyway, here we got three commands at hand. Firstly, for 2D patterns, we got create UV curve and apply curve, and also for creating the 3D patterns, we got flow long surface at hand. So, let's get back to the Rhino 8. Suppose that here we got a simple surface. Firstly, I draw a rectangle. After that, I want to use rebuild to increase the number of control points, and then I select some of them to curve the surface, or I want to adjust it in a vertical way. Watch this. This is my surface that I want to. Firstly, let me hide the ISO curves on the surface, and then I want to create a simple pattern at the beginning of the video. However, you can consider whatever surface for yourself as an example or practice, but the process is fixed. Firstly, we start the command of create UV curve, and then we select it to create the UV curves and the points of the surfaces on the plane. Suppose that we got a geometry in a CAD software, and then we import it to here, and I don't want to start drawing it on the surface from scratch like this way. I just want to use a pre-created drawing or geometry and then to transfer it on the selected or desired software. I'm in surface. Firstly, we have to project it on the plane or create the UV curves and points on the plane, as you can see. And after creating the UV curves and points on the plane, and then from the top view, we should draw the desired pattern on the surface. Suppose that we draw some circles, and in order to propagate them quickly or to just array them randomly, we'll talk about all of them. Anyway, after drawing the geometries or the pattern inside the loop or the enclosed geometry or the curves, however, we may have these patterns prepared, or we may have downloaded them, and also we may wanted to import some vectors from some softwares like Illustrator or Corel or some other CAD softwares. I put them inside this region, then we select them, and then I start apply curve command. Then if I click on the surface, they will apply it on the surface. I mean, the 2D patterns will be applied or projected on the selected surface. Watch this, and they will be deformed based on the curveness of the selected surface. Then you may want to cut your surface using these patterns, using split, and after that you can assign new colors or the new layers for the selected cut parts, or we can create some frames or panels for them like this way. Check it out, and then consider a section for them or profile. Then you can consider pipes for them or some other things. So the first thing that we talked about was create UV curves. For creating the UV curves and points of the selected surface on the plane, and also apply curve for transferring the 2D patterns on the selected surface. Control Z. Right now, suppose that I want to modify the surface like this. Then I start create UV curves command. Then we'll have an approximate UV curves and points out of the selected surface. Watch this. Still we got the rectangle. So note that we're always given a rectangle despite of deforming the object or surface. And then if I add some circles and make them copied and paste randomly like this way, and then I want to select and apply them on the surface, then you'll see that these circles will be deformed as well, just like the deformed surface. Watch this. Seems that they are impressed that we can use such a capability here. Let me tell you another point. Suppose that I want to array the circle. We are just talking about some basic and symbol commands. Here if I hold down Alt button, and as you're concerned, I have hidden the isocurves. Watch this. Here in Properties Object, I have unchecked Show Surface Isocurve. Like this way, as you can see at the right side of the screen. Like this way. Anyway, I just want to make some copies out of the selected circle. Firstly, we select the object, and then by using array, rectangular array, we array this object, for instance, 8 in X direction, and 8 in Y direction, and 1 in Z direction. Then I adjust them graphically like this way, by selecting a point by this way. Then for controlling their spacing, for instance Y spacing, for instance 8.2 or 9, watch this, we can easily array them by selecting the single object and then select apply curve, applying them on the deformed surface. And as you can see, they are deformed as well. Control Z, then I can make the surface planar, create UV curves, to create the UV curves and points. Then if I draw a pattern outside of the circle, outside of the UV curves, or the region, when there is an intersection between the pattern and the perimeter of the rectangle, then let's check out the results actually by applying the curve. You'll see that we'll have the intersection between these two elements as well. Watch this. Here it is. So, what are the boundaries here? What are they used for? So, can we select the circles and then apply them on this circle? Watch this. Yes, why not? But the boundaries are like this. Watch this. And they won't be applied on the surface accurately. But when we create the UV curves, we can define the spacing between the patterns or to the boundaries. And the next point here is that in some cases we want to adjust the circles in some specific positions. For instance, I have drawn some two lines on the surface, and then I create the UV curves. Watch this. The lines are not created. So here we have to select the curves to create the UV curves on the plane. Then we can draw the patterns on the plane and then apply them. Watch this. and make sure that they are drawn at the center. And then apply curve. Check this out. Look, great. In the continuation, I want to have a pattern that the circles are being minimized after one another. Let's see. Without editing the surface, since I don't want to revise the surface. Firstly, let me draw some circles here, or um, skewers. Watch this. I select the skewer, then I resize it, select it, and then I want to start array. I set it to fill 8, 8 and 1. Afterwards, I set it. Let me increase the numbers. I set it to 10 for both directions, like this way. Let me make some copies out of the surface to show you the results. Then apply curve, select and watch this. Then here we got a command that even the Rhino users may find it new, which is scale each. I start the command of scale each, then I press down enter, which is a hidden command that we started. Here we got some modes. The first one is normal, that we can scale all of the patterns together like this way. The next one is gradient. Watch this. This is the result. We can scale them, and also we can specify the scale factor. We can specify 1 for the one side and the other side at 0.1. And then I can apply this on the surface. Check this out. And let's check the others. I make a copy out of this array field like this way, and then I adjust it inside the boundaries. Scale each. I start this command, and then I select the patterns. I set it to random this time. To random the patterns, to scale the patterns randomly. Watch this. Select, apply curve, and selecting the surface. And after applying them, I can select the surface, choosing split, then selecting the patterns, then cutting the surface. Look, I can select the surfaces or the panels, delete them, or moving the surface. Look, and if we wanted to extrude them, we can use offset surface toward outside, not 0.5 for the offset, like this way. Or I can select the surface, split, selecting the patterns or the rectangles, and wait for a second. I lock them, and then I change their layers. Watch, to show them in new colors. So we talked about a symbol command, create UV curves, and apply curve.